All right, I'm going to go through a few things on here. If you have any questions as we go, does everybody have a review? I pushed for the quiz back a day, so. Everybody else has one? All right. Number one, just make sure that it's in standard form before you identify anything, because if this is all mixed up right here, then the term out in front is not the leading term, right? And so that changes everything. So just make sure that it is truly in standard form before you identify anything that's going on. 2 is when we did that in behavior test, the leading term test, to try to determine what the in behavior is. I know that you can put that in the calculator, but sometimes the calculator doesn't give you a real good picture of the graph, and so it could be a little bit misleading at times. And so that's why we use that in behavior test, or the leading term test, to determine that. A couple people asked me about this yesterday. There's a couple problems like this on the review here and on the quiz tomorrow. This one is simply just asking us to take 2 and plug it in. If it's a 0, we'll get an answer of 0, okay? If we get an answer of anything other than 0, then it's not, okay? Later on in the review, it's going to ask you to do synthetic division. And so you can either do synthetic division and get a remainder of 0, or you can just simply plug it in. And frankly, I don't really care which way you go with it, because both of them determine that. So there's a couple different ways to do it. This one is plugging it in. Later on, it's going to be synthetic division. So both of those do the same thing. 4 and 5 are basically the same question. The only difference between 4 and 5 is 4 is in factored form, 5 is not in factored form. Okay? Factored form is a little bit easier. What I will tell you is, a couple people asked me about the 3 yesterday. The 3 does not have an X attached to it. Okay? That would be like taking a GCF out. Sometimes there might be an X attached to the 3. If there's an X attached to it, I got to set it equal to 0. Okay? This one does not. So it doesn't do any good to set 3 equal to 0, because we know 3 does not equal 0. You can't solve for X. So you would have to set X plus 6 equal to 0. You set X minus 6 equal to 0. Solve both of those out. Your multiplicity is your exponent. So this one has a multiplicity of 2. This one has a multiplicity of 3. Okay, number 5, we have to factor it ourselves. And this one, we did one like this on our notes last week. When it's in this quartic polynomial, we don't necessarily recognize it because we're used to doing this with quadratics, but in this case, it's product and sum. It could be product and sum, it could be grouping, it could be slide and divide, it could be any of our factoring methods, okay, maybe even DOPS. So in this case, here's where you got to be careful on this one. X to the 4th would be x squared times x squared. Okay. When we did this with quadratics in the last chapter, it was x squared at the beginning, so we did x times x. Well, here, because it's x to the 4th, we would do x squared times x squared. Then we got to find the 2 numbers that make that work. What multiplies to get 8? What adds to get negative 6? And so that would be a negative 4 and a negative 2. Okay. Those are my 2 factors, but then I got to find my zeros. Okay. And there's a couple different ways that you could do that. This one is DOPS, this one's not, okay? Because this is not a perfect square right here. So for the x squared minus 4, you could do x plus 2 and x minus 2, which is DOPS. For x squared minus 2, we can't do DOPS because it's not a perfect square. So we're just going to set that equal to 0, and then we're going to solve for x. And so on this one, it would be that square root method. I'm going to add 2. And I'm going to take the square root. Okay, so here's the thing. How many zeros do I have to account for? 4, right? And so my zeros here would be plus or minus 2. Because when I set both of these equal to 0, this would give me a negative 2, this would give me a positive 2. And this one over here would be plus or minus radical 2. You need a review. So that's 4 different zeros, right? 4 different solutions. What would be the multiplicity of those 4 zeros? 1. They all happen one time. So we would say they all have a multiplicity of 1. Because if I have 4 different zeros and I have to account for 4 zeros, then they can only happen one time. Okay, number 6. This is a little bit different, but it ties into everything that we've been doing. It's just more of kind of like a story type situation. So we're talking about throwing this stone. It's kind of a physics type problem, but physics and math pretty closely related. So here's the equation that represents the situation. The 34.3 is part of the formula right here. Okay? The 4.9 t squared is just part of the formula. If a stone is thrown downward at 34.3 meters per second from a height of 215.6, and up here it tells me that the height is s meters, or travel a distance of s meters. And so the 215.6 is how far it's traveled. And so what we're going to do is we're going to plug 215.6 in for my height or my distance. Okay, if they told me the amount of time, like if they said we're going to throw the stone for 5 seconds, then I would plug 5 in for t, right? So t is time, s is distance or height. I want to solve, this is a quadratic equation. So what would be, there's a lot of different methods we could do here, right? We could use any of those methods that we use to solve quadratics, but what's our go-to to solve a quadratic? Or what do we have to do first before we do anything else? Got to set it equal to 0. Okay. Okay. And I can tell you right now, I don't want to do the quadratic formula. I don't want to try to factor this because of the decimals that I have. A lot of those are going to be pretty difficult to do. So what's always our go-to to solve? Graph. That would be our first thing we're always going to look at. Now I'm going to show you what's going to happen here when we graph this. If you want to put it into your calculator too, just to kind of verify what's going on here. And so we would say t equals 4. You don't have to list both because it's a story problem. The negative 11 doesn't make sense. Okay, this one here, based off of the degree. So as I look at number 7, what is the degree? 4, okay? That's the first thing we have to decide. The degree is 4. If I have a degree of 4, it's asking me 3 questions here. How many real zeros can I have? 4, okay? How many x-intercepts could I have? 4, okay? How many turning points could I have? 3. It's always one less. So 4, 4, 3 is what we want. That's it. Turning points is always one less. X-intercepts and zeros are always the same as the degree. That is the most that we could have. Okay? And so all you got to do, and make sure it's always the highest exponent. If it's not in standard form, don't necessarily look at the first exponent, look at the highest exponent. Something to watch out for. Hey, this is just another way of asking you the same thing as number 2. This is essentially the same question as number 2. Now here's what I will tell you about the 4 graphs. Look at the 4 graphs, and you may or may not have noticed this, but this one is up, up, this one is down, up, this one is down, down, this one's up, down. You have your 4 options here. They just are giving you the graph. So all you have to do is look at the leading term and tell what it's going to be. Okay, so immediately, if this is cubic, then what's that tell me about my graph? Here's what I remember. Okay, if it's odd is my exponent. 3 is an odd number, right? Odd will be in opposite directions, one or the other. Okay, odd and opposite. They're going to go opposite directions. Hey, thanks. They are not in here. No, I think they might have taken BSAT. So you might take the testing room. And then if this is negative, it's going to start up and end down. Okay, so then D would be our answer there. Okay. Can you put it into the calculator? Yeah. I mean, and it's not wrong to put it in the calculator, but once again, sometimes the picture that you get in the calculator might be a little bit distorted based on what the function is. Hey, you don't have to do all of this stuff on number 9, but this kind of ties in all the things that we've been talking about as we've gone throughout a lot of these polynomials. One thing that you could notice, okay, is that this is cubic, so it's going to be down, up, because we have a positive coefficient. So immediately I could eliminate D. That's definitely not it. And I can eliminate A because that one starts up and ends down. Okay, so immediately I can eliminate those two. Once again, can I just put this into my calculator? Yeah, okay, and I'm not telling you that you can't, but I'm just telling you why all of these things come up. And then you're looking for your zeros, okay? And then it should be pretty easy to determine from your calculator, but if you wanted to, I mean, you could factor it, you could do all kinds of things. You'll see some of the work that I show, like I take out the x squared and things like that. So do you have to do all that? No, especially since it's multiple choice, but there's a lot of things that we've done that you may not even have to put it into the calculator. But probably not a bad idea to still do it to check it. Okay, I told you yesterday, number 10 is the only one that I'm going to ask you to do long division for. Okay, and I'm not going to ask you to do one on the test either, because it's just, I know that synthetic division is our go-to. There are times where we will have to do long division, and so it's still something that we need to know how to do, okay? But synthetic division is going to be our go-to most of the time. So I'm going to ask you to do one problem by long division, which is number 10. Can you check it by synthetic division? Sure, I don't care if you do that, but in order to get full credit for this question, you would have to show all the work for long division, okay, along with that. And then also notice that you're writing your answer in this format here. D of x times q of x plus r of x. This is the divisor. The divisor is what we're dividing by, d of x. Q is the quotient. It's what we get like on top of the long division. That's my quotient. And then r of x is your remainder. So divisor times quotient plus remainder is what those stand for. That's the only time you have to write your answer like that, okay, just on number 10. So number 10, a couple of different things about that one that make it a little bit different. If you need help with that one, let me know. I know long division is not our favorite, but that's still something I want you to at least practice. Number 11, a couple of things that I want to point out on this one. First of all, if they give us a factor, if we're dividing by a factor, x plus 2, what's going to go in our box? Negative 2. Okay? Always the opposite. What we get when we set it equal to 0. Like on number 12, if I did synthetic division with it, 2 is what's going to go in the box. Okay, so if it's written as a factor like x plus 2 or x minus 2, then we always do the opposite. If it's a number that's all by itself, that's the number that goes in the box. So make sure you remember the difference between those two things. X plus 2, we're going to put negative 2 in the box. We're going to do our coefficients. 1x cubed, negative 1x squared, and then here's where you got to really be careful. 0x, because we're missing an x. Okay, we got to make sure we get that 0 in there. And then 5. And then we're going to go through synthetic division. Okay, now I got this question a lot yesterday, and I get it because a lot of times what we've done is we've always ended up with the remainder of 0. Do I have to end up with the remainder of 0 here? No, okay? Only if it says this is a factor or this is a 0. We're just saying divide by x plus 2. I'm not telling you that it's a 0 or a factor. So maybe I end up with a remainder of 0, but I may not, right? So don't think that you have to end up with a remainder of 0. The only time you have to is when we know it's a 0. And then on this one, when you write your answer out, you just have to write it with whatever the polynomial is with the remainder, if there's a remainder. If there's no remainder, then you don't need a remainder. Okay, 12 and 13, those are the ones, especially because these are multiple choice. You can do synthetic division if you want. I know that's what the directions tell you to do, but it's also like page 1 where you can just take those numbers, you can plug it into your function, and I'll tell you a real quick and easy way that, I mean, especially if you got a couple of numbers you have to check, rather than plugging it in or doing synthetic division, then I would simply just put this into my y equals. I would look at my table, and I would look at 4 and negative 2. If the y value that matches up with 4 and negative 2 is 0, then we would say yes, it's a 0. If my y value is anything other than 0, then it's a no, okay? So that would be a really quick and easy way of evaluating both of those. Okay, 14 is asking for 2 things, and you got to have both of these to get the points on this question. It's asking us to factor it, and it's asking us to solve it. So when we write out our answers, we're going to say factors, and we're going to solve. Now, I think I told you this yesterday, but if not, then this usually would be a grouping question. But I'm just going to tell you right now, when it's 4 terms, we can try grouping, but in this case, grouping does not work. Grouping doesn't work all the time. And we don't really have an alternate factoring method. So I'm going to show you a really quick way to come up with the factors, kind of working backwards. So the first thing we're going to do is we're going to put this into our calculator. Okay? We're going to graph this function. Your my factors are the factors that would give us that. And they're always going to be with an x. So x plus 4, x minus 2, and x minus 5. And those would be my factors. Okay. So we use the zeros to write the factors. It's always going to be x minus whatever this is. If I were to multiply these 3 together, that would get us back to there. Not that you have to do that, but just understand what the factors tell us. Those are the factors that multiplied together would get us back to that. Okay, I'm going to kind of show you what I'm looking at or looking for on a problem like this. It says to use synthetic division in the remainder theorem to find the zeros. Once again, and I've said this a lot today, but can I use my calculator? Yes, but I kind of want you to show a little bit of work, and that's where the synthetic division comes in and how it all kind of works together, okay? So, first thing we're going to do, can I graph it? Can I put it in my calculator? Absolutely, okay? And so here's what we're going to do. We're going to put this one into okay, and if you want to go ahead and draw a sketch of this graph, it doesn't have to be perfect. We're just using the sketch to help us identify the zeros more than anything else. we're going to go through synthetic division. This is where I have to end up with a remainder of 0. We already said 2 is a 0. If I don't get a remainder of 0, then I've done something wrong. Okay? So that's where it's a non-negotiable. You got to have a remainder of 0. What I have left over here is a quadratic. So there's two options that you could do here. I could put -3 in synthetic division, or I could write this as a quadratic and I could factor it. Okay? You could write this as x squared plus 6x plus 9, and you could factor that polynomial. And it would factor into x plus 3 and x plus 3. But I'm going to show you another way. And I kind of prefer this way, because I think it's a little bit easier maybe. We know that -3 is a 0, right? So if we go through synthetic division again, and we did one kind of like this yesterday, we get a remainder of 0. Okay. Well, what does this mean? We started with a cubic, and then we were to a quadratic, and now we are to a linear polynomial, right? 3, 2, 1. We keep breaking it down by a degree. So we would write this as x plus 3. If I set that equal to 0, I would get x equals -3. And so here's what I'm going to do. You could either go 2, -3, -3, and list -3 twice, or you could say 2 and -3 with a multiplicity of 2. Okay. And that shows you that. If you would have factored at this point, you would have got x plus 3 and x plus 3, which is x plus 3 squared. So that's just another way of showing you that. You get -3 with a multiplicity of 2. Okay. So the synthetic division just kind of puts it all together. And it makes, sometimes we use synthetic division if like we have a imaginary solution, which I'll show you here in just a second. Okay, 16. We're going to write out the factors, x minus 5, x minus 2i, x plus 2i. There's my 3 factors. We kind of did that earlier on the review. We're going to multiply this all together because we want a standard polynomial in standard form. Whenever we multiply these, always do the conjugates first. Don't try to multiply this by this because it's going to get really tough and it's going to get really nasty to try to do that. So just trust me. Always do the conjugates first, get that answer, then multiply x minus 5 times that. Okay? I'll give you a little hint here. Your answer is not going to have an I in it, okay? And so a lot of times when people see the I's, they're like, oh my gosh, my standard form is going to have it's going to have I's in the polynomial. It won't, because when I multiply these two together, the I's are going to disappear, okay? So it's going to look just like a normal old polynomial. And it's going to have a degree of 3. 3 is telling you the degree. 3 is not a 0, right? So sometimes that confuses people. The degree of 3 just means it's x cubed. And so when I write it out, it should say something x cubed with the whole polynomial. Okay, on 17, this is that theorem that we talked about the other day. If I had -3 as a 0, does that also make +3 a 0? If -3 is a 0, then is +3 always going to be a 0 along with it? No. The only time we do the conjugates is if we have an I or a radical. Okay? So if I have 3i, then I have also -3i. If I have negative radical 3, then I also have positive radical 3. So if it has an I or a radical, it always has a conjugate. That doesn't work for an integer like -3. So here, I have 2 other zeros. I have a degree of 5, so I have to account for 2 other zeros. And so that would be C. Hey, number 18 is very similar to number 16. and this ties into the one we just talked about. If it has an I, it always comes in pairs. So x plus 5i, x minus 5i are my two factors for that. X plus radical 5, x minus radical 5 are also two factors. So it's going to be a degree of 4. I'm going to multiply all this together. So a little hint here, and I'm going to let you guys do the multiplication, but multiply your i's together, multiply your radicals together, get those two answers, and we'll have to FOIL one more time. So you got to FOIL 3 times on this one. Okay, number 19. Given a function and one of the zeros is 3, find the other zeros. The first instinct for a lot of people here is to put it into the calculator, okay? And that's not a wrong thought, but if we put this one into the calculator, there's no way for me to find those other zeros on my calculator. So that's where synthetic division is going to come into play. We're going to put 3 into the box. We're going to bring down 1. Okay, and once again, we have to get a remainder of 0. We already know that 3 is a 0. I have to get a remainder of 0. If you don't get a remainder of 0 there, you've done something wrong. Okay? I already know that 3 is one of my zeros. So it says find the other zeros. You probably don't have to list out 3, but I'm going to list out 3 because we already know 3 is a 0. I got to find the other 2 zeros here. So we're going to write this. We started as a cubic. We're going to write it as a quadratic. And you can use any of the methods that we've talked about. You can try to factor it, but it's not going to factor, okay? You can do any of the methods that we did. You could do completing the square if you want to, but no thanks, right? So what's going to be our go-to here? Quadratic formula. Okay. There it is, okay? I'll keep it up here for you. You just need to know how to use it. There's A, there's B, there's C, okay? And once again, a hint here is your answer is imaginary, okay? I'm just giving you that hint. So it's going to have i's in it. And there'll be 2 of them because it'll be plus or minus with your quadratic formula. So that's what accounts for your 2 other zeros. So I'll let you finish that one out. Okay, the last 2. This one is where we do that P over Q. P is -8. Q is 2. We're going to list out all the things that could be zeros of this. Not all of them will be zeros, okay? And you don't necessarily have to solve this one. We're just looking for a list of numbers that could be possible rational zeros. That's why we call it the rational zero theorem. Okay, so P is 8. We're going to list out all the things that go into 8. Q is 2. So we're going to list out all the things that go into 2. We're going to take all the top numbers divided by all the bottom numbers. Well, if I divide 1, 2, 4, and 8 by 1, that's pretty easy, right? It gives me back 1, 2, 4, and 8. Now remember, you got to put plus or minus on each of these possibilities. And then we're going to take all of these and divide it by 2. So we're going to go 1 divided by 2 is a half. Then we're going to go 2 divided by 2. Well, if I do 2 divided by 2, it gives me 1. We've already got 1, so I don't need to list it again. 4 divided by 2 is 2. We've already got it, don't need it again. 8 divided by 2 is 4. Already got it, don't need it again. Those are my zeros, okay? Or possible zeros, not actual zeros. So we have 5 different numbers, but we actually have 10 possibility for zeros, okay? And each one has got a plus or minus on it. Okay, the last one I will tell you here is, put this one in your calculator. Find out where it touches or crosses the x-axis. Those are your zeros. And then use that to figure out what the multiplicity is. And we've done several problems like that throughout the review, where here's my zeros, here's my factors, which one matches up with that. Okay, so just put it in the calculator. Okay, I tried to do a lot of stuff here. Any questions that you guys have so far on any of that? Armani?
Second to last one, how do we find when we put on the top and on the bottom?
So P is always your constant, okay? So that's 8. So we're gonna list all the factors of 8, everything that goes into 8. Okay, so that's why I put a P here next to that. And then Q is the leading coefficient, which is 2. And so we're gonna find all the factors of 2. Okay, so all the stuff here in the middle, we don't need to worry about that. The 7 and the 13 doesn't have anything to do with anything. Okay, does that help? Okay. Any other questions that you guys have? Ava?
Like on this.
Okay.
Yes.